Good morning. My name is Ari Chambers, and I'll be your moderator for today's webinar. 2 notices before we begin. First, if you're joining the webinar via mobile device, please note that you'll have the option of viewing a panelist or the presentation, and you may change your view by simply swiping left or right on your screen. Second, we encourage you to ask questions throughout the webinar using the questions chat section on your screens. At the end of the presentation, I'll read out your questions for the panelists to answer. With us today, we have AJ Patel and Justin Jasona. AJ is our business development manager and has over a decade of experience in the oil and gas industry, including time as a reliability engineer and maintenance and planning execution lead. Justin Jasona is our technical consultant and project manager, as well as a NACE Level 1 coatings inspector with 10 years of experience in coatings and repair materials. Just to go over our agenda for today's webinar, we're going to review what corrosion under insulation is. You'll see it throughout the presentation as CUI, why it occurs, how Belzona can help, and we'll review a couple of case studies that you can reference related to CUI. I'm going to pass it over to AJ to get us started.
Awesome, Aria, thank you so much for that introduction, and good afternoon, everybody. Happy Thursday. On this beautiful June day. So as Aria mentioned, our conversation today is going to be about corrosion under insulation. If you happen to tune into our last webinar, we actually talked about process safety management, and corrosion under insulation was actually one of those areas that when we talked about it from a preventative perspective was something that if you have a process facility, this is something that is definitely of importance to you. So the first question is, what is corrosion under insulation? Put simply, it's a severe form of localized corrosion that happens under insulation, hence the name corrosion under insulation. And it's primarily driven by the environment in which your operating facility exists. And so when we talk about environment, 2 key areas, we're talking about the temperature, and temperature in this case is what's the temperature of the process that's actually going through the pipe, and then conditions, so things external to the pipe itself, pipe or equipment, I should say. So conditions external to it. Temperature, obviously one of them. Marine environment, are you in an area where you have a lot of moisture in the air because you're by an ocean, etc.? Is the weather where you're located hot and humid? Do you experience a lot of rainfall? Is there a lot of wet-dry cycling? Is there a lot of hot-cold cycling? Anywhere there might be steam tracing, if you have a situation where you have cold winters and you need to keep your process fluids warm, steam tracing is often a source of the moisture that helps accelerate corrosion under insulation. So that's something to be thinking about. And finally, sweating pipes. So now you've got a warm environment, you've got a colder process, and your pipes are going to sweat. That insulation going to lock it in. So these are the types of environments that we're talking about that you want to really think about if you're concerned about corrosion under insulation. So a couple facts. CUI is a big deal. Congress did a study back in 2001, and they found that the cost of CUI on an annual basis is about $276 billion dollars per year. That's a very, very large number, and it's a huge opportunity for your plants to take a look and say, hey, where can we make some corrections? 81% of CUI leaks occur in pipes that are 4 inches or less. That was done by a study conducted by ExxonMobil. Some other results of their study were that the highest incidence of leaks actually come from corrosion under insulation concerns, and 40 to 60% of piping maintenance costs are related to CUI. So when you take a step back and you think about, hey, how can I operate my plant in the most safe manner? How can I prevent loss of primary containment? And what can I do to keep the cost down? CUI is a great place to start. So what's at risk? So several materials, really 2. Carbon steel, I think basically intuitively people can understand the idea of carbon steel. It's highly exposed to things, especially when it comes to corrosion. We'll get into that in a second. But also 300 series stainless steel. What sort of equipment? Really anything made of these 2 materials. Pumps, tanks, vessels. You can think about valves, control valves, instrumentation. So these are the areas that you want to start looking at. So why does CUI occur on carbon steel? So, it's good to take a step back and ask ourselves, why are we insulating the piping in the first place, right? So in this case where we see the most aggressive type of CUI, it's generally temperature range between 150 and 300 degrees. And so why do we insulate that pipe in the first place, or why do we insulate that equipment in the first place? Well, those temperatures are very hot. They're hot to the point that if somebody was to actually physically touch them, they could get burned, they could get hurt, they could get injured. So safety first. Number one thing we're always concerned about is safety. So that's one of the reasons why we insulate that equipment. The second reason why we do it, well, you want to preserve that energy. That's, you know, in any kind of a process situation, if you have something that is of a certain temperature, you want to preserve that energy and use it in another part of your process, because you want to keep your process as efficient as possible. And energy savings is always a target, especially for process facilities, to do this. So we wrap this equipment in insulation. And insulation, for the most part, is just porous. You put it around the equipment itself, and then you're going to wrap it in an aluminum cladding most times. And what happens is that in the aluminum cladding, if you follow my marker here, you know, this little gap here would generally be filled with a caulk. But if you have any kind of hot cold cycling throughout your seasons, guess what's going to happen? That caulk's going to break, and it's going to snow, or it's going to rain, or you're going to have moisture in the air, and it's going to work its way into this insulation. Conversely, if you have steam tracing, you don't even need the gap in the cladding. If you've got a steam tracing leak, guess what? That steam tracing is going to get out. It's going to saturate your insulation. Then what happens? Well, you've got this hot process fluid going through your equipment, and sometimes it's hot enough that it'll cause the moisture to start flashing off, and now you've got this flash condense cycle that's happening in a contained area continuously over and over and over again. It starts beating up your pipe from externally, so you actually get more of an erosion type wear of it as well. It starts beating up on that metal, it starts eating it up, and then along that, and if we expand it a little bit and we start talking about, well, all right, we're not so hot, so should we really be concerned? Well, it's not going to be as aggressive. However, it's still an exposure, because anytime you have a base metal and you've got humidity or you've got some kind of a moisture, that insulation is still going to hold on to that moisture. And what happens when you have carbon steel and you've got water and you've got oxygen? You're going to have oxidization, and essentially your pipes are going to rust away from the outside in. So it's just very, very important to understand that you are exposed to CUI whenever you have conditions 350 degrees and below. Really, for the most part, it's just a conversation around how rapidly is this going to happen. So stainless steel is another area where you could potentially have CUI issues. It's a little bit more complex. It works a little bit differently. So you have what they call chloride stress corrosion cracking. These are micro cracks and prick pits that will happen on the stainless steel itself. Generally, it happens and occurs because of a presence of chloride. Well, where does this chloride come from? Well, the insulation you might be wrapping your piping in itself may contain some of these chlorides. And if they do and they're not properly spec'd, you're going to end up with an issue because of that. Also, if you are proactive and you try to put in a coating in place, that could also have chlorides as well. So this is why it's very, very important to have conversations with your Belzona rep, because we actually know what our coatings are made of, and we'll make sure and ensure that whatever you put on your stainless steel piping isn't going to create a bigger problem. And finally, seawater. So anywhere you might have salts in the air, that's another prime area where CUI could occur with stainless steel, because once it gets in there, it's got no way of working itself out. It sits on that stainless steel, it starts working its way in, and creates these cracks. Here's the problem. You can't really see them with the naked eye. You actually have to do a little bit more detective work. So you got to grab your inspection group, and what you have to do is you have to bring in some electromagnetic test coils, and they basically, check around the equipment. They put some magnetic pulses in there, and what happens is it's called eddy current testing, and they have a meter that they feed back, and it generally shows like a normal wave coming back to say, hey, this metal's good, we don't see any problems. However, if defect signals start coming back, then you know that you've got some areas that you've got to be concerned about when it comes to CUI. So what do? How do you investigate it further? First, you want to clean that area, because essentially those cracks, those little micro cracks, micro pits, they're going to be filled with dirt. So you're going to want to clean them out, and then we're going to apply what they call liquid penetrant. And this liquid penetrant is going to be able to work its way into the crack itself. We're then going to clean it off. You're still not going to see anything. Believe it or not, you're still not going to see anything. And then we're going to put a developer on there, and that developer is going to pull this liquid penetrant out of the actual base metal itself, and that's when you're going to start seeing crack indications. You're going to start seeing and understanding, hey, this is what's going on. And at that point, we can have a deeper conversation around, hey, what is it that we do to address this issue? We can look at wrap systems. We can look at different ways that we could rebuild the strength of that metal while it's in service to allow you to continue to operate. And so this is another important area. Again, our conversation here is about being proactive. Let's get after the problem before it happens, and let's make sure that you can continue operating your facility in a safe way. So with that, I'm going to go ahead and play for a video for you. So there's no sound, so just be aware of that. And this is a hot water tank that had some corrosion under insulation. We're going to zoom in. We were called in to take a look at this. As you can see, there's plenty of insulation. And right in this area here, you're going to see a jet of water shooting out. So I'm going to play that, and then we're going to toss it over to Justin Jasona, and he's going to go through some examples for you. All right, Justin, how you doing?
Hey, thank you, AJ, for that. And Aria, much appreciated on the introduction. Welcome, everybody. Thank you for being with us today. AJ got a little bit into the technical aspects and reasoning as to where to look for CUI and why it pops up in the field. And what I'm going to do now is go over a couple of classic cases and examples and case studies in the field in which we've experienced CUI and corrosion under insulation. So if you follow my laser pointer right here in the red, you'll see the little graphic right here. And basically what's happening right here is water has found its way into the insulation and it's beginning to corrode the external of the pipe. So at that moment right there, as AJ kind of mentioned a little bit earlier, once there's a break in the insulation and water finds its way in, it's pretty much where it all starts and how it all begins. This particular example of these two images on the far right and middle are basically examples of a customer who called us out to come take a look at their tank that was insulated. And as you can see, they were taking a proactive measure and approach to limit their corrosion under insulation. If you can really follow the laser pointer right here and see there's general corrosion beginning to occur. And basically the customer was doing what they were supposed to and being responsible and trying to protect their equipment. So they called us out to the job. And once again, this is definitely the approach you have to take when you start to have insulation removed or start to see breaks in the insulation. And this is where the corrosion all begins. What we have here is a cooling tower header piping repair. And in this particular situation, this piping was actually powering the HVAC and air conditioning system of a local university president and dean's office. So as you can imagine, it was a sensitive situation because we had to get in there and be as minimally intrusive to the pipe with removing the insulation and surface preparation to get some sort of resolution for this customer. Had this pipe blown, there would be no air conditioning and HVAC system for the important people at the university, and we'd have some unhappy customers basically. So again, right here you'll see with the laser pointer a bunch of corrosion buildup under insulation scale, and obviously when we removed it, this is a picture right here of the elbow, we did find several different weep holes, through holes, and quite a bit of metal loss. So how do we resolve this? You'll see the afters and durings right here. We addressed any of the leak holes and weep holes and even some of the lower through hole areas with Belzona 1000 series super metal and epoxy composite paste as a stopgap. And once those areas and leaks were plugged and the metal was rebuilt, we were able to install on the elbow right here a Belzona Super Wrap 2 composite repair system to wrap and protect the corrosion under insulation and have continued corrosion protection and rebuild some of the structure. And then further on from that, we went a step further and provided the customer with a UV stable barrier coating protection because we were pretty much unsure at that point when they would be able to get insulation back on the pipe. So again, another situation where Belzona 1000 series came into play, and we were able to keep the customer up and running, and end result was a happy result. Hot water tank. AJ did play a quick, brief video for you guys before. We were, tasked with the situation of coming to the job and seeing a live and active leak. The customer was able to take this out of service for a day, but however, this tank was actually a pretty crucial part of their process. This particular piece of equipment was powering some of the hot water that they needed to run chemicals with to produce their products, and they did not have any time or leeway to basically shut down for extended periods of time to repair the tank completely or replace it, if you will. So what we had to do was be careful with removing the insulation. AJ already showed you the video. We uncovered 10 to 12 different leak spots on the external, some that were located closer to the welds. And if you could follow my laser pointer right here, you'll see some of them. And once we removed all of the scale buildup and located all of the through holes with inspection, we were able to isolate these areas with another Belzona 1000 series stopgap and use an epoxy composite paste. And then the end result was us wrapping the tank again with the Belzona Super Wrap 2 system to keep the customer running. The downtime was overall probably 24 full hours, and the end result was the customer being thrilled with the solution that Belzona was able to provide. Refrigerated water piping, you'll see the graphic up here with the ice cube. This is our Belzona 5871 thermal insulation barrier coating protection cool to touch property coating system. So you'll see the cool to touch properties from the graphic here, where on one side of the pipe it's not coated and the ice cube is melting, and on the other side with the Belzona coating installed and cured, there's no melting going on at all. So this particular situation, the customer had their refrigerated water piping and they had some form of a mastic wrap insulation system on it that they thought was, helping insulate the pipe. It actually wasn't. So when we went there, we removed some of the insulation. And again, we were as minimally intrusive as we possibly could without damaging and disrupting the pipe in their service. We did find some through holing. We found some significant metal loss. And as you can see right here in this middle picture, just a ton of general external corrosion. And then this would be the end result right here. After we installed on the T-pipe 2 coats of Belzona 5871 to provide this customer with a solution in regards to insulation as well as CUI and corrosion protection moving forward. Tank bases, we talked a little bit about this earlier. Anything that's insulated and anywhere there's going to be a break and any tank that's outside, water will find its way into the tank. It'll break apart and saturate the insulation, and it'll begin to work its way down to the bottoms and bases of tanks. So as you can see where the laser pointer is pointing out right here, tons of scale buildup and even potentially through holes. And this is really not a good thing for customers. So what we want to focus on here is taking a proactive measure and approach to, inspection and basically anything that's insulated. And as far as tank bases goes, Belzona does offer one-part epoxy systems that are heat activated and surface tolerant, as well as tank-based seal systems that you'll see right here to keep water out of the area and to let any kind of corrosion insulation run off of it, basically. So again, for image purposes and graphics purposes, this is an example of what tank corrosion under insulation could lead to at your base, and this is an example of what it could like if Belzona epoxy systems and composite repairs are carried out properly. Another great example of a cooling tower T-pipe, as you guys can see right here, we have about half the wall thickness of the pipe that once was, let's say. So when we removed the insulation, and that's what this photo is right here, we discovered half the pipe was gone and that there was a couple of different weep holes and through holes. So again, another great example of how we addressed these leaks and this corrosion under insulation with a Belzona 1000 series epoxy paste to get a stopgap on the pipe to basically isolate the leaks. And then from there, perform different kinds of surface prep to get the pipe looking like this, which is your end result after the Super Wrap 2 composite wrap system and a protective barrier coating around the outside of it. So again, before, after, and Belzona basically came into play in all these different examples of CUI. And that is where we're at from here. I believe at this point in time, we are going to open it up for a Q&A and bring the group back in. So thank you guys for being with us today.
Well, thank you so much, AJ and Justin, for a great presentation. As AJ mentioned before at the start of the presentation, corrosion is a topic that we touched on and addressed in previous webinars. So if you're interested in viewing past webinars, reading case studies, or exploring any of our Think Big solutions maps, please visit our Big Learning Center. You can do so by visiting the link below or by going to banksindustrial.com and selecting Learning Center in the menu bar. And with that, we'll go into Q&A. It says here, our facility uses inspection ports to check for corrosion issues under insulation. Is this a good part of CUI practice?
Well, yeah, absolutely. And when we talk about CUI, and really when we talk about anything that's about PSM, it's always about the entire encompassing plan. So what is the result of the inspection port being where it is? It's identifying like the conditions we talked about. Maybe you have between 150 and 300 degrees. You know that you have insulation around that particular piece of equipment. And so the logic drives and says, hey, this is equipment I need to be paying attention to. So that's why that inspection port exists there, right? It's not just for the internal part for the corrosion, it's also to check externally. So it's just one part of a broader strategy that starts with identifying where we're most likely going to have a problem and then putting together a plan that says, hey, this is potentially an area where we're going to have a problem. Let's monitor it. What we say here at Belzona is, fine, you can monitor it, but you're just going to monitor it to a point where you have a problem. We would prefer you to say, hey, we know this is going to be a problem. Let's also take some mitigative steps as well before anything actually happens, some preventative steps. And let's put some coding systems in place that could potentially stop this from ever even getting to the point where we have to worry about it.
Awesome. Thank you, AJ. Justin, I'm going to throw a question over to you. How do you ensure that surface prep does not cause hole-through to the CUI damaged surface? And how much is too much surface prep?
Okay, well, the short answer to that question would be just being extremely, extremely careful and as minimally intrusive as you possibly can to the pipe. We're tasked with some pretty difficult situations where the customer is asking to remove a bit of the insulation and potentially expose what we already know in our minds could be a live and active leak. So it would be good to have a plan as a backup with the customer that can you temporarily shut this pipe off. That would be the place to start. However, how much surface prep is too much will basically remove what is visibly, creating that external corrosion to kind of nip it in the bud and find good anchor points on opposing ends of where that particular section is to basically, perform extensive prep too, because we know the metal's better in those areas, and basically use surface tolerant Belzona epoxy composites to stopgap the areas that do unveil themselves as pretty difficult scenarios and live and active leaks and things like that. So using SSPC 1 and SSPC 1 and 2, basically solvent cleaning, hand tool cleaning, and just being very careful with the power tool cleaning would be the best form of keeping it up to just protecting yourself basically. So I hope that answers the question.
Yeah, and if I could just jump in right on what Justin was saying, there actually are Belzona products that also don't require the surface prep, and they are specifically designed for CUI. In fact, I think Justin may have touched on it during his presentation, but if he didn't, we can get that information out as well. So you don't always have to surface prep, because the fact of the matter is, as Justin mentioned, when you're peeling back insulation, there's some steps that should be happening before that. Pre-plan, 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 pre-plan. If you're in a refinery, I know we used to do HAZOPs. So, if you know that you're, again, similar to the question with the portholes, right? Inspection ports. We should have a generally good idea of what we can expect when we pull back the insulation. We know where corrosion under insulation happens. We know where these exposed opportunities are. So we should be planning in advance, because it's all about safety. We don't want people getting hurt. We don't want people getting sprayed. So we want to take every precaution necessary to make sure And when we go in and we engage with whatever issues we have, we're doing it in an absolute safe manner. So safety first, pre-plan, pre-plan, pre-plan. If you have to go as far as a HAZOP, you do that as well.
Awesome. Thank you both. Related to knowing where those areas of CUI have already occurred, AJ, could you speak a little more to the dangers of randomly removing insulation from areas that you know are already impacted by CUI? And do you have any for avoiding a blowout? Sorry.
Yes, no problem. So again, just to reiterate what I said, do not randomly remove insulation. It's not good practice to just say, hey, you know, we've got a leak, we're just going to rip off the insulation. You don't want to do that. If you know, first of all, if there's a leak, right? If the reason why you're going after this specific area is there is a leak, then you know you have an active leak. There should be a pre-plan. That's just the bottom line. Somebody should reduce the pressure on that pipe. Somebody should isolate it. Something should be happening, because you don't want to put people in a situation where, hey, we know the line's leaking, let's just take off the insulation. You're going to get sprayed in the face. If you suspect a leak and you suspect CUI, you have to treat it the same way. You don't want to go in head first and just say, I'm going to start ripping off insulation, because the fact is that insulation might be holding the slimmest piece of metal up against that, you know, pipe or that pump or whatever equipment it is, and you might peel it away and cause the problem. So you might not be seeing the effect of CUI, but you know, it's definitely going to be there. And that's why we say what lies beneath. It's a hidden danger. You don't see it happening until you actually experience it, because you've got a whole nother layer that you're not able to visually see through to tell you, hey, you've got a problem here. One thing that you can do, if I can add on there, Aria, is at times if you use, and in fact in our previous webinar, we actually showed an elbow that we had super wrapped. And this, you know, when we went back and we took x-rays of it, you can actually visually see where you lost the barrier. So potentially an x-ray could help you with that as well.
These have to be the option.
Awesome. Thank you so much. I'm not seeing any other questions at this time. So we're going to wrap up for now, but you will receive a follow-up email to this webinar that will have a recording of the webinar so that you can rewatch it or share it with others that may be interested. It'll also include the emails for both AJ and Justin, so if you do have further questions, you can reach out to them directly. Thank you all for attending.
Yeah, Aria, one other point before we leave. I just for folks who have tuned in, thank you for tuning in. One thing I really want to stress is that our objective here is to help you get ahead of the CUI issue. You know, so when we talk about these problems, these are things that we would like you to think about and look at inside of your facilities, and then reach out to us. And we're more than happy to come out, take a look, help you investigate these issues, and be a part of the solution that can help prevent something bigger from happening. And, you know, it goes without saying, we're on the 1-year anniversary of what happened at Philadelphia Energy Solutions. And that's where I grew up. In my oil and gas career, I had a lot of friends that are actually on this webinar and attending, but also a lot of friends that work there, a lot of great experiences, and a PSM issue is ultimately what shut that place down. And, you know, CUI is just another PSM issue that you want to be aware of, because it's a leak, but it's a leak that can turn into something bigger, and then now you're talking about bigger consequences. So really, we want to be a part of the solution. We want to be a part of helping your facility continue to operate as long as it can. Thanks everybody for attending.
Thank you.
Thank you so much.